Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
Welcome to Solving Rational Equations. The big deal here is that you're going to notice that you have an equation, which means there's going to be an equal sign. When we have an equation, you're actually going to find values of x that make the statement true. So our big goal here is to clear fractions. That way we can work with these in our traditional way. However, before you clear fractions, you must first note any values that x cannot be. And that would be values that cause domain errors. And since we're talking about ratios, that's when the denominator equals 0. That's when those domain errors are going to happen. So I like to clear fractions by multiplying everything by the LCD. Some people like to get everything to have a common denominator and then ignore the denominator. Technically, this does the exact same thing as multiplying by the least common denominator. You'll get to the same step. That's actually how you can ignore it, is when you multiply by it, it cancels it out. So that ignore it is kind of like an quote thing. Or some people like to get each side to one ratio. And then they like to use cross products. And that works out very similar. There's just a slight adjustment on that one, but we'll get to the same answer no matter what. So we're going to go ahead and look at one that's already set up to where it's a single ratio in each side so that I can compare this version with this version. So our first example is going to read 3 over x equals x minus 2 over 5. I'm actually going to compare all three. So if I were to get a common denominator, my common denominator would be 5x. So if I multiply this side by 5x, and I multiply this side by 5x, here we would get 15x over x, but the x's are canceling out. So we just get 15. Here, the 5's will cancel out, and we'll be left with x over x minus 2. Okay, if I rewrite that, the problem was 3 over x equals x minus 2 over 5. If I look at that cross products, 3 times 5 is 15, and x times x minus 2. There's that cross products version. Or if we get everything to the same common denominator, times 5 times x times x, and then ignore it, all three methods we're getting 15 equals x times x minus 2. So all three methods are going to work for you. It's just a matter of which way your brain is happiest. Again, I'm going to choose multiplying by the LCD most of the time, least common denominator, but you can work with the other methods as well. As we can see now that we have this, once we distribute, we're going to have a quadratic. So we need to make it equal 0. And up here, I should have noted before we started that x cannot be 0. If we get 0, we have to kick it out. It'll be an extraneous root or an extraneous answer. If I factor, I get x minus 5 times x plus 3. If you forgot how to factor, go back and watch one of my factoring videos. And then the zero product property says that each equal to 0. So I get x equals 5 or x equals negative 3. Now, if I didn't have to show work and I had access to technology, I could just go ahead and graph it. And I have it typed in here as the original. And we see that it is crossing at 5 and crossing at negative 3. If you ever wind up with ones where you can't actually click on it, so see how it's not letting me click? We're going to come in here. We're going to subtract everything to one side so that it equals 0. I'm just not going to write equals 0. And now I can tap on it. So if you're utilizing Desmos and you're trying to find out where it crosses the x-axis and it's not letting you touch on it and pull up the points like this, move everything to one side by adding and subtracting your fractions. And I would do that before doing any work. And that way you don't have any sign errors or things like that going on. And it will help you verify your answers. It is always good to verify your answers. It's not necessary, but it's a good idea, especially if you're worried about it on a test or something. All right, so let's get into some more. 3x minus 1/2 minus 1 over x. Now remember, this 3x is technically over 1. That's something that many people forget about. So because I have 2 and x in my denominators, my least common denominator would be 2 times x. So I'm going to distribute 2x to both sides. So 2x times 3x, which also note x cannot be 0 because of this fraction right here. All right, so we wind up with 6x squared. 2x times 1/2. That would be 2x divided by 2, and 2x divided by 2 is just x, because remember this is technically over 1. And 2x times 1 over x is just 2. And 0 times 2x is 0. It's quadratic, it equals 0, but our coefficient is not, our lead coefficient is not 1. So I'm assuming you probably don't want to factor this one. So we'll go ahead and use the quadratic formula. If you don't want to factor, you can always quad formula. So negative b plus or minus, there's our square root, b squared. Again, put that squared on the outside of your parentheses if you've heard me talk about that in the formula for the quadratic formula video. 4 times a times c all over 2 times a. All right, let's see what we got here. 2 times 6 is 12. We have 1 plus 48, so it would be 49 for our discriminant. That's nice. We can do the square root sign. I find that some people, when they actually do the square root, they forget that they've done the square root and they keep writing the symbol. Please don't make that mistake. So here we have 1 plus 7, which is 8 over 12, or 1 minus 7, which is negative 6 over 12. So we are getting 2 answers. We'll go ahead and reduce those. 3/4 or negative 1/2. Sorry, not 3/4. Wow, what am I thinking? 8 does not divide by 3. How about let's divide them both by 4 and we get 2/3. My brain took a break for a second. I know you wondered for a second what I was thinking. Okay, so we've got 2/3 or negative 1/2. Again, if you wanted to substitute them back into the original problem, which was there in purple, that would be a great way to check. Neither of our answers is 0, so they are both in the allowable domain, so we're good to go there. X plus 20 over x minus 4 equals 5x over x minus 4 minus 2. When I look at this, I see 2 ways that I could quickly do this problem, and I happen to like both of them, so I'm going to show you both ways. Method 1 is going to be multiplying everything by x minus 4. And the reason why x minus 4 is because that's the LCD. Okay, so that would give me x times x minus 4. When I take this fraction and I multiply it by x minus 4, the x minus 4s will cancel out and I'll be left with 20. When I take this fraction and I multiply it by x minus 4, the x minus 4s will cancel out and I'll be left with 5x. And when I take minus 2 and I multiply it by x minus 4. So for those that canceled out, I'm just going to write it in pencil. When I take 20 or 5x, when I take your fraction there and I multiply it by x minus 4, remember that x minus 4 is over 1. So that's why it's canceling out. And it's doing the same for both this term and this term. So by multiplying by the least common denominator, I have cleared out my fractions. Now I can go back to solving algebraic equations, noting that x cannot equal 4. Okay? Why? Because that would zero out my denominator, causing a domain error. So x squared minus 4x plus 20 equals 5x minus 2x plus 8. Keep in mind that negative distributes through. Sign errors are one of the most frequent problems that I notice in these. The right side is not simplified, so I'm going to simplify it before anything else. 3x plus 8. Now it's quadratic, so I'm going to make it equal 0. X squared minus 7x plus 12 equals 0. So let's solve that by factoring since the leading coefficient is 1. I get x minus 4 multiplied by x minus 3. So x either equals 4 or 3. However, that 4 was a domain error. So the answer is x equals 3 because x equals 4 is extraneous. It's like an extra root. It worked in the quadratic once we cleared out our fractions, but it did not work in the original problem. So we call that an extraneous root. Okay, so I said we were going to have two methods to solve this one. With method 2, I noticed that 2 of them are just a simple number or variable, and 2 of them are ratios with the same denominator. So method 2, I'm thinking like divide and conquer. So I would have x plus 2 equals 5x over x minus 4 minus 20 over x minus 4. And I see that common denominator there, so I could write them as a single fraction. And then, technically that's over 1. Now I can just cross product. X plus 2, x minus 4 equals 1 times 5x minus 20. So x squared plus 2x minus 8 equals 5x. Sorry, this should have been a negative 2. X squared minus 7x plus 12 equals 0. And now I'm right back to the same steps. So it depends on which approach you want to handle that with, that you would have that going. But you would get the same answer. So x is only going to equal 3 because 4 is an extraneous root. Okay, so here I see this rational equation, and I notice that this is prime, and this is prime. The reason I know they're prime is there's no exponents in the parentheses and there's no GCF in any of the parentheses. So my least common denominator is going to be 3x minus 4 and 6x minus 1, noting that x cannot equal 4/3 or 1/6. So I'm going to multiply each term by this, and this time instead of just writing the next step, I'm going to write out what it looks like to go ahead and distribute. And I'm not going to write it out to the front. I'm just going to distribute it to both sides of the equation immediately. So 3x minus 4, 6x minus 1. 3x minus 4, 6x minus 1, 3x minus 4, 6x minus 1. Now our 3x minus 4s are going to cancel that out to clear that fraction. The 6x minus 1 clears that out, and the 3x minus 4 clears that out. Now there's no fractions left, and we, instead of a rational equation, we just have a polynomial equation. So we're left with 2x times 6x minus 1 equals, notice the parentheses. It's always important to group things. They were understood in the original, so. And the other thing is it'll help us with our sign errors. Okay, now we get to do some algebra. Distribution, we get 12x squared minus 2x equals 12x squared minus 16x plus 15x minus 20 minus 18x plus 3. So again, watch for sign errors. The right side is not simplified, so that's my next step that I'm going to do, is I'm going to combine like terms on the right side. Negative 16x plus 15x, that gets us to negative 1x, but then we're going to subtract 18x, so we have negative 19x. And negative 20 plus 3 is negative 17. Now that it's simplified, if I subtract 12x squared from both sides, it's no longer quadratic. So this term cancels that term. So now it's linear. That makes life easier. I'll just add 19x over. And x equals negative 1, which is neither of our domain errors, so we're good to go. Okay. See if we can shorthand a little bit more now. We know that x cannot be 2 because that would cause a domain error. Multiply by 3x minus 2 because everything was already factored in prime. X minus 2's would cancel out, leaving us with 3x. The 3's would cancel out, leaving us with 2 times x minus 2. And the x minus 2's would cancel out, leaving us with 2 times 3. So we have 3x plus 2x minus 4 equals, I should have used parentheses there, that would have been better, 6. Oh, come on, refocus. Let's see if I can't focus here. All right, so I'm going to add these together and get 5x minus 4 equals 6. So 5x equals 10. X equals 2. Uh-oh. I only got one answer, but I said that answer couldn't work. X equals 2 is extraneous. We have to kick it out. Therefore, we are left with no solution. These will never be equal because the only place they potentially could have been equal is at 2, but 2 is a domain error. So this equation has no answer. With a problem like this, I have found students that just go ahead and start multiplying everything by this parenthesis, and this parenthesis to cancel out their denominators. And the problem with that is that they end up, if you do that, you're going to wind up with a very large degree or power on your x value. So please, please, please remember to first factor your denominators that are factorable, and this one happens to be. So we have x minus 2 over x plus 3. And I'm going to change this to plus negative 1. That way I don't make a sign error. And this factors to x plus 3 times x minus 2. So our side note is, because of this, x cannot be negative 3. Because of this, it cannot be 2. Because of this, negative 3, which we already have, and 2, which we already have. So now when I multiply everything by my least common denominator is just x plus 3, x minus 2. Distribute that. Now, on the right side, both quantities cancel out. Here the x minus 2 quantity cancels out, and here the x plus 3 quantity cancels out. We're left with x minus 2 multiplied by x minus 2 plus negative 1 being multiplied by x plus 3 equals just 1. There's nothing left for it to multiply by. Distribute. Minus 2x plus 4 minus x minus 3 equals 1. So x squared, it would be minus 4x, but then we have a minus 1x here, so minus 5x. 4 minus 3 is 1. Now I'll subtract the 1, so it equals 0. So now that I have it equaling 0, it's quadratic. This one happens to have a GCF. Makes it really easy. Set each parenthesis, because technically this is a parenthesis, equal to 0. So we're getting 0 or 5. Both of those are good answers because they do not mean we have domain errors. It's okay for x to be 0, just not the denominator to be 0. X over x minus 1 minus 2 over x plus 1 equals 4x squared over x squared minus 1. So again, I like to write this as x over x minus 1 plus negative 2 over x plus 1 equals 4x squared, and I'm going to factor this, x plus 1, x minus 1. So x cannot equal 1 or negative 1. So my GCF is going to be that x plus 1, x minus 1. So x plus 1, x minus 1, x plus 1, x minus 1, x plus 1, x minus 1, parentheses. The x minus 1's cancel, leaving us with x squared plus x. I went ahead and distributed that together right quick. The x plus 1's cancel, leaving us with negative 2x plus 2. Both cancel, leaving us with 4x squared. So x squared minus x plus 2 equals 4x squared. In this case, I'm going to move everything to the right because I like having a positive a value. So make this side equal 0. So that will give me 3x squared plus x minus 2. And you could use a quadratic formula, but these are prime numbers, so I'm actually going to factor it. We know 3x squared is 3x times 1x. We know 2 is 2 times 1. If I put the 2 here, it's going to multiply the 3 and make 6. So I'm going to put 2 here and 1 here. That way this inside is 2x and the outside is 3x. So we need positive 3x minus 2x to make that 1x. Set each equal to 0. And again, if you didn't follow that, you can go back and watch one of my factoring videos. That's my guess and check method. Add 2, divide by 3, subtract 1. Uh-oh, that's extraneous. 2/3 is my only solution. So again, always verify for those extraneous solutions. Okay, 3 people are planting a garden. Working together, they can get the job done in 20 minutes. Working solo, person A would take 50 minutes, and person C would take 15 minutes longer than person B. How much time would it take person C? And I understand that it sounds like there's not enough information to figure this out, but there really is. Okay? So, together, they take 20 minutes. Person A is 50 minutes. B is X minutes. And C is 15 minutes more, so X plus 15 minutes. I just used a variable since we didn't know. I know a lot of people, when they go to work together, they just try to add these 3 to get working together, but it makes sense that if you're working together, it should take less time. So that's why together is 50 minutes, where person A would be solo 50 minutes by themselves. So the problem is we need to be able to compare rates. Because we can't actually compare total time, we have to be able to think of it as a rate. So the bigger question is, what part do they complete each minute? Okay? So person A does 1/50th of the garden each minute. So person B would do 1 over X. We don't know how long that is per minute. And their C would do 1 over X plus 15. per minute. Now, when you combine those three together, they do 1/20th of the garden each minute. So here we're going to be looking at what part do they do per minute so that we can add those up, because that is something we can add up. And once we know what part is completed per minute, we actually end up finding out how long it takes person B, and then therefore how long it takes person C. So let's look at that horizontally. And that's going to equal 1/20. So we can see here that this fits right into this lesson because now we have a rational equation, so we're going to have to multiply by the least common denominator. So this can be a little bit tricky. So let's first focus on the number 50 and 20, both go into 100. This denominator has an x. This denominator has an x plus 15, and those are actually both prime. So therefore, that's going to be our least common denominator that we multiply everything by. So I'm just going to call it 100x, x plus 15. Looks just a bit neater. Okay, I have it distributed to everything. So 50 goes into 100 twice, leaving us with 2x, x plus 15. X cancels x, so we'll have 100, x plus 15. X plus 15's cancel, so we'll have 100x. 20 goes into 100 5 times, so we'll have 5x, x plus 15. Distribute, 2x squared plus 30x plus 100x plus 1500 plus 100x equals 5x squared plus 75x. Combine like terms, 2x squared plus 230x plus 1500 equals 5x squared plus 75x. I like everything to have a positive a value, so if I subtract everything over, I'll have 3x squared. We'll have minus 155x, and then minus 1500. So there is no GCF here, and the factoring may or may not be nice, so we're going to just go ahead and quadratic formula this. X equals negative b, plus or minus, we'll have our radical, and we'll have b squared minus 4ac all over 2 times a. That gives us 155 plus or minus 42,025 for our discriminant. And that would be over, I wrote 2 times 2, it was supposed to be 2 times 3. I was looking at the wrong line. So we get 6 for the denominator. So one thing you can do is you can actually type that into your calculator. I have it typed in here to Desmos, and I have it all in there, and I get 60. So 60 minutes could be our x. Or, because it's a plus or minus, right? Delete that, make it a minus. It could be negative 8 1/3 minutes. We can't go back in time, so negative 8 1/3 minute doesn't make sense in this issue. So remember, sometimes in word problems you have to use realistic answers, and negative 8 minutes is not realistic. So we found out x equals 60 minutes. So this person would take an hour to plant the garden. X stood for person B. but they asked us how much time would it take person C. So if this person is taking 60 minutes because they do 1/60th a minute, then person C would take 75 minutes, and that would be your final answer. So make sure when you are answering word problems that you answer them as the correct answer, not just what your variable equals. And in this case, we can see that by comparing minute rates, we were able to get a total minute rate together, basically comparing apples to apples because we're looking at a minute rate, not a garden completion total. And we were able to add it together and solve. So anytime you have those working together problems, it's usually a good idea to go ahead and approach them in this way. Make sure whenever you're completing these that you do check for your extraneous answers, and always verify your answers if you did not do that.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.